I'd like to draw an analogy to where Steam Deck was, right? If you think back to the original Steam machine way back when, we threw that out there. We learned a lot from that experiment. We learned a lot that we had to go back and do more work, right? And that's how Proton came into being. That's how we knew we had to simplify the ability of partners to put content on the device. And by the time all that work had been done and ready, it sort of came to fruition for the Steam Deck. I think it's in a very analogous thought process for this device. So the Steam frame draws upon a lot of the technology from Valve Index and sort of that VR catalog, but it also, we had to wait until the computing technology was on the headset for us to have not just a good streaming experience, but we wanted SteamOS and ARM and all of that support VFX, which is the ability to allow us to play content locally. We wanted those all to come together to be able to create a device that really breaks those boundaries and lets you do both. So I mentioned this earlier, but I think one of the real superpowers for this device is to not have to choose before you put it on whether you want to play VR or non-VR content. So I love the Index, I love my Steam Deck, but I would very often have to think before I picked up one of those devices, am I interested in playing a VR game? Okay, go to the room with a VR system. Or do I want to pick up my Steam Deck and play that catalog? With the Steam frame, you don't have to make that trade-off. You just put it on, you have your Steam catalog in front of you, and you can just browse through it and see what you feel like doing. And so for us, the reason we're doing it now is because we can finally create that lower friction experience that really lets you think about it and being able to enjoy that full catalog in a different way.
Yeah, and I think one of the things that also goes into that is when we think about the streaming experience from the PC obviously can run, your entire Steam catalog. So we wanted to make that streaming experience as seamless as possible. So you're looking at your Steam catalog in front of you on your headset on the Steam frame, and you can easily choose if you want to play a game streamed from your PC, both 2D games and VR games. And so that process right there, once again, the friction is super, super low, and you can basically say, I want to be able to play local content, I want to play streamed content, and you really don't have to be taking the headset off, putting it back on, and that friction is as low as we could get it.
We would have loved to have built this device 5 years ago, but the technology just wasn't there for us. We really had to wait until all of the compute and the form factor that's only recently become possible, and that's why now is the time for us to build this device. We have sort of three things together that create a really great streaming experience. The first one is the dongle. So people might be familiar with streaming, and they might be familiar with some of the challenges and gotchas involved with streaming. I think people, when they think about streaming, they might think about the cloud, where you have some computers at a nearby data center, and then they send that information across the internet, and they send that information across your home's Wi-Fi, and when it finally hits your device, there's a certain challenges enjoying that type of content. With the included wireless link, we take all of that out of the equation. We have a direct connection between the headset, talking to your PC or your laptop, where you don't even have to think about it. It's designed to be plug and play. You plug it into your device. Steam just directly makes that connection, and you don't have to think about when you hit the play button, whether it's on your local device or whether it's streaming. We've also done one other thing in conjunction with that, which is the eye tracking in the headset. We showed this to you earlier, but we do a new technology. We're calling it foveated streaming. A lot of customers might be familiar with foveated rendering, where you spend more of the PC's compute ability to render the pixels where you're looking. This is not that, but it is similar in spirit to that, but applied at the transport layer. So we call it foveated streaming, where we send the highest quality information, essentially full fidelity for the area you're directly looking at, and then the rest of the scene is sent at lower fidelity. And that trade-off gives us a much higher effective bandwidth. So say, for example, the foveated area is 1/10 of the size of the frame. You can think about it as an effective 10x multiplier in bandwidth and quality improvement you get from that. So those two things together, or really three things, are what let us have a streaming experience we're really proud of and that we think everyone will be able to enjoy. It's not just about the antenna, it's about all of the trade-offs, right? So there's only some number of channels in the spectrum. There's there's always errors that happen, like forward error correction. There's always trade-offs, and so you're really balancing bandwidth, robustness, and latency because of retries and things like that. And there's no magic bullet, right? There's no magic solution. So us being able at the system layer to introduce this multiplier, this 10x factor, really just gave us like link budget for free in being able to spend that. So even if we made it a more powerful radio or a more powerful link, I would still want to bring this technology and apply it in this case because it just makes things better.
The same team that's working on SteamFrame, we all worked on Index, right? So we definitely have the history of, all of the different VR headsets that have been made over the last 10 years. And so, we've put on a lot of headsets on our faces and we've said, okay, how can we make our own headset that really does a really holistic job where we say, okay, let's put as low of a weight as we possibly can on the person's face. Let's get the battery someplace else. Let's put it in the back. Let's put the charging port, the Type-C port in the back so that if you happen to be using a additional battery in your pocket, for example, that cable would be in the back. We have, the facial interface that's as soft as we possibly can. We've iterated like crazy to make that as comfortable as possible. We've, made the audio that's built in on the sides of the head strap as high quality as possible. We're always trying to shave weight, make the eye tubes as small as possible. We're basically just constantly wanting to make the device as lightweight, as comfortable as possible so that when somebody puts the device on their head, they immediately feel comfortable and they're thinking, okay, what content do I want to enjoy right now? What game do I want to open? And they're not thinking, man, this thing is uncomfortable, right? And so there's a huge focus on comfort. And then within that, saying, okay, what performance can we squeeze out of the chip that's in here? How much battery life can we get? And then having that ability to have a very high performance wireless link to your PC. So, we have a very high-end radio that's on device. We have a very high-end SoC that's in there as well. So all of these things all together are really basically saying, within this package, how can we get a really high performance device that feels good on your face and that you're going to be happy to put on and not be immediately thinking, man, I really don't want to be wearing this thing right now, right? So that's a huge thinking process.
I think one of the consistent threads throughout all of the Valve hardware projects is that we use the devices ourselves a lot.
Yeah.
So I know some more traditional types of hardware organizations, you might have a team that's responsible for the battery and another team that's responsible for the processor and another team that's responsible for the software. And they're very dedicated, independent teams. But one of the challenges with that type of organization is that it's sometimes hard for that feedback to make it across and to be acted upon. And similar to our game teams, where I don't know if people are familiar with how our game teams work, but they're very sort of an ad hoc organization where you sit by who you're working with and anyone could give feedback on any system. Valve hardware works exactly the same way. So if I'm wearing the headset every day, writing software or working on the user interface, and I have feedback about the weight in the front and exactly how it fits, I walk over 20 feet, I tell that to the designer, and then I'll have a new version the next day. I think all of us acting as real users and play testing these things every day, as well as being so closely tied to the interdisciplinary engineering where you can just literally walk across the hall and talk to someone who's working on something radically different part of this design, has just allowed us to turn the crank really quickly and go through a whole bunch of iterations. And that's one of the reasons I think we are uniquely able on small teams to do such awesome devices. So the FOV is up to 115 degrees. They're pancake optics. So people are familiar with those from other sort of top tier premium devices. That pancake optical design is a folded optics system where it has both refraction and reflection, and that allows you to have a very compact, small form factor, which really helps the ergonomics, as well as still getting sharpness edge to edge over that up to 115 degree FOV. The panels are 2160 by 2160 per eye. They're LCD. They allow for refresh rates from 72 hertz up to 120 hertz, and then 144 is allowed as well with we call it experimental mode. Exactly the same as Index, actually. We have integrated cameras. There's 4 monochrome cameras on the exterior doing tracking. They're specifically designed to be very good at tracking, as well as very good at doing that in low light. They pair with integrated IR illuminators, which allow you to track in certain environments in complete darkness. We also have 2 cameras on the inside for eye tracking, which, as we discussed, is a large advantage for streaming. We also, just to talk about the APU a moment, we also have 16 gigabytes of RAM that's standard, and then the processor.
Yeah, the processor is a 4 nanometer Snapdragon Generation 8. It's a Snapdragon 8 Gen 3, also known as the 8650 platform. And that is a very, very capable processor right now that combines together a ton of things as far as being able to talk to all of the different peripherals, as well as the very high performance wireless solution. All of it goes together with essentially running SteamOS now on ARM. And what's really cool about that is that allows us to bring together a whole bunch of different ecosystems onto one device, both on the VR side, the non-VR side, whether it's streamed, running content locally. And we also have 256 gigs as the base SKU for storage, 1 terabyte option. And we also have an SD card slot. And the SD card slot would allow you to plug in, 1 terabyte, 2 terabyte SD cards. And that's, something where you could even take, for example, your SD card from a Steam Deck and plug it directly into the headset. And now you have your games running right there. Another option there would be, or another interesting detail there would be, we do have the camera expansion port on the front that has 2 different modes, a high-speed camera interface as well as a PCIe port. So a lot of interesting modularity and functionality there.
Yeah, there have been a lot of awesome games that have come out in the last few years. So I think we're really excited about where it's at, and even going forward. One of my favorite thoughts is that VR feels like a little bit of a segregated island from non-VR gaming. I know on Steam, very often you think about it as there's VR users and non-VR users. But when we look at the playtime data, what we see is it's blended a lot more than that. A lot of the people who play VR also play non-VR content, and that's one of their major decision factors in us deciding to come to market with this type of product.